Hi guys, welcome back. In today's session, we are going to understand what is a circuit breaker and how to implement circuit breaker in our Spring Boot application. So first of all, what is this circuit breaker? Circuit breaker is a design pattern in microservices. So by using this circuit breaker design pattern, we are going to implement fault tolerance systems. The main purpose of the circuit breaker to implement fault tolerance systems. Whatever the fault tolerant systems we are developing, they are also called as resilience systems. So what is the meaning of resilience or fault tolerance? Fault tolerance system means when main logic is failed, instead of sending exception to the user, we need to execute a fallback logic. That is called fault tolerance. Now, simple example. So here I'm having one method in my project. Okay, assume that the method is M1. Inside the M1 method, there is some logic available. Okay, when this logic is executing, if some exception occurs in this M1 method, then my program will be terminated abnormally. So, but what I want to do is, whenever some exception occurs in the M1 method, then immediately I want to execute M2 method. This M2 method contains some other logic, fallback logic is available. So when M1 method is failed to execute completely, then I want to execute M2 method logic instead of sending the error to the client. Client is sending a request. Whenever client request comes, M1 method will execute the logic and will send the response. If M1 method is failed to execute successfully, then immediately I want to execute M2 method. That is called fallback logic execution. In order to implement that fallback logic execution, we are going for circuit breaker. So what is a circuit breaker? Circuit breaker is a design pattern in the microservices. People will call it as a design pattern. This circuit breaker is used to implement fault tolerance systems. Fault tolerance systems are also called as resilience systems. This fault tolerance system means when main logic is failed to execute, then we should execute fallback logic to process client request. Okay, I have explained one simple scenario here. I have a class. In the class, I am having a M1 method. My M1 method contains some logic. When the M1 method logic is failed to execute, then I want to execute M2 method. That is my fallback method. Now, that we can implement like this. Okay, see here, public void M1. Inside this, some logic will be available, and I will write some try block, and I will write some catch block. Now, you can ask a question, sir, whenever exception occurs, it will go to catch block now. Then in the try block, some logic is available. Whenever exception occurs, it will go to catch block. Inside the catch block, I will call M2 method. So now we can do like this also. So here logic is available. Here M2 method is available. Whenever exception occurs in the M1 method, I want to execute some fallback logic. So when exception occurs in the M1 method, to execute the fallback logic, we are going for circuit breaker. Some people may ask a question like this, Ashok, why we need to go for circuit breaker? Whenever exception occurs in the M1 method, try block will execute, in the logic will execute. When exception occurs in the logic, then immediately it will go to catch block. Inside the catch block, I will call my M2 method. We can do like this also. But the real power of the circuit breaker is not only executing the fallback logic. We can configure circuit breaker in such a way, whenever request coming to M1 method, now first time the request came for the M1 method got failed to execute. Then second request came for the M1 method, that also failed. Then Third request came for the M1 method, that also failed. So every time request is coming, the request is failing in the M1 method. Now I will configure a circuit breaker in such a way continuously. If 3 requests are failed, then don't call the M1 method, then directly call the M2 method for a next 30 minutes. For a next 30 minutes, you call the M2 method. But if I go for try catch block, what is the problem? Always my try block will execute, it will fail, then it will go to catch block, will call the M2. Again for second request, try block will execute, it will fail, it will go to catch block and call the M2. Third request will come, it will execute the try block, it will fail, go to catch block, call the M2. So like this, multiple requests will be coming. Every time it will execute the M1 method try block, it will fail, it will go to catch block. But in the real time, fault tolerance will not be available like try catch. So what is the fault tolerance system is, now I have M1 method which is having a logic to execute. If 3 requests are continuously failing with the M1 method, then there is no use of calling the M1 directly. From the fourth request, we call the M2 method without calling the M1 method. For next 30 minutes, my M2 method will be executed. After 30 minutes, a request will be retried with the M1. So now when I send a request, again M1 is failed, again M1 is failing, then for the next 30 minutes, only M2 will execute. So that is the meaning of circuit breaker. Circuit breaker is used to execute fault tolerant systems with some fallback logic. When the main logic is failed to execute, then we will open the circuit breaker to execute the fallback logic. So that is called fault tolerant systems. Guys, now are you able to understand what is a circuit breaker and why we are going for circuit breaker? Are you guys able to understand what is a circuit breaker and why we are going for circuit breaker? Come on, guys. So what is circuit breaker and why we are going for circuit breaker? What is circuit breaker and why we are going for circuit breaker? Circuit breaker is a design pattern. Okay, circuit breaker is a design pattern. What we are trying to achieve by using circuit breaker design pattern? What we are going to achieve by using circuit breaker design pattern? We are going to execute fallback logic when the main logic is failed. It is used to develop fault tolerance system. When the main logic is failed, then I want to execute the fallback logic by using circuit breaker. So to develop resilience systems, to develop fault tolerance systems, we are going for circuit breaker. Clear? I'm repeating once again, observe. I have M1 method and I have M2 method. Whenever the request is coming to M1 method, if it is executing successfully, then no problem. When the request comes to M1 method, if it executing successfully, then no problem. Suppose M1 method is not able to execute, M1 method is failing. 3 requests came, M1 method failed for 3 requests. Continuously, when 3 requests are failed, then from fourth request, I want to call directly M2. My fallback method should be executed for next 30 minutes. After 30 minutes, a test request will be going to M1. If it is success, then okay. If it is not success, then fallback logic will execute. So to execute the fallback logics in our application, we are going for fault tolerant system development with the circuit breaker. Now let us see how to implement that circuit breaker and what is the another use case for the circuit breaker. Let me give another scenario where people will use circuit breaker. Now assume that this is my microservice, my REST API. My REST API want to get some data. To get the data, we are using Redis server. Redis cache is available. Our application want to get the data from the Redis server. And similarly, we are having the data in the database also. This is my DB server. Redis server is available and the database server is also available. Okay, so now to improve the performance of the application, I want to get the data from the Redis because DB operation will be always costly operation. So now here I have a method called get Redis data. Get Redis data. Some logic will be available. And here get DB data. Some logic will be available. Okay, and here to get the Redis data, some logic is available. Get the Redis data and get the DB data. Now, getting the data from the Redis server is our main logic. Getting the data from the Redis server is our main logic. Okay, and getting the data from the database is our fallback logic. So first of all, when the request comes to my application, I want to execute my first method, which will get the data from Redis server. Okay. Suppose if it is not able to get the data from the Redis server, if the Redis server is down, so do you want to send error to the client saying that the data is not available, or we need to get the data from the database and send it to the client? Always I don't want to get the data from the database because getting the data from the database is a costly operation. It will take a lot of time because query should be created, connection should be open, driver class should be loaded, connection open, create the statement, execute the query, get the data, close the connection. So DB operation is costly operation. So to improve performance of the application, we are using Redis cache in our project. Cache is used to store the data for temporary purpose. Now, my microservice want to get the data from the Redis server. If I'm able to get the data from the Redis server, all good, no issue at all. Suppose if Redis server is down, our application is running, people are accessing our application is trying to get the data from the Redis server, but all of a sudden, Redis server is not responding, Redis server is down. 3 requests came, 3 requests continuously failed because of Redis server is down. When 3 requests continuously failed because of Redis server is down, is there any use to execute the same logic for the 4th request and 5th request? No. Already 3 times it failed. 4th also will fail. 5th also will fail. 6th also will fail. So that's where we are going to implement circuit breaker. When one logic is failing, I don't want to send the error to the client. I want to execute fallback logic. My fallback logic is getting the data from the database. If data is coming from the Redis server, we are good. Suppose continuously 5 requests failed with the Redis server. Then from 6th request, I want to execute only DB method, not the Redis method, because Redis method already failed 5 times. 6th time also it will fail. So let us break it. Let us break it. No need to call that method because it is already failing. 5 times already failed. Then from 6th request onwards, I want to execute only DB data method to get the data from the database. For 30 minutes, I want to execute only second method. After 30 minutes completed, again, let us retry with the Redis method. If Redis method is working, then okay, we are good. We'll continue with the Redis. After 30 minutes also, if Redis is not working, then again, our circuit breaker will open. Still we'll continue with the database method. So whenever main logic is failed to execute, then we want to execute our fallback logic for some time. So to execute the fallback logic for some time, after that retry with the main logic, we are going to use circuit breaker. Circuit breaker is a design pattern in the microservices. Circuit breaker is a design pattern in the microservices. Whenever some exception or whenever some problem occurs in the main logic, then we want to execute the secondary logic, that is nothing but fallback logic. So when the main logic should execute, when the fallback logic should execute, that will be decided by circuit breaker based on the execution status. If a first method is not failing, then always only first method will be executed. That will get the data from the Redis server. Suppose if the first method is failing continuously for 5 times, then there is no use of executing the first method. 5 times it already failed. From the sixth request onwards, I want to execute only secondary logic, fallback logic for 30 minutes or 40 minutes. After 30 to 40 minutes completed, let us retry with the main logic once again. If main logic is recovered, then we'll continue with the main logic. If main logic is not recovered, then we'll continue with the fallback logic. So when to execute the main logic, when to execute the fallback logic will be decided by circuit breaker based on your application execution status. Circuit breaker is a design pattern which is used to develop fault tolerant system. People will also call it as resilience system. Now you got the clarity? What is main logic and what is fallback logic? My application should get the data from the Redis server. That is important for us. Suppose if we are not able to get the data from the Redis server, continuously for 5 times, if we fail to get the data from the Redis, then from 6th time, I want to get it directly from the database, not from the Redis. Are you guys clear? Are you guys clear with this? Clear? Good. Just quickly read this. What is a circuit breaker? Just to read these points, guys. What is circuit breaker? Just read these points. What is a circuit breaker? Circuit breaker is a design pattern in the microservices. It is used to implement fault tolerance system. Fault tolerance systems are also called as resilience systems. Fault tolerance system means when main logic is failed to execute, then we should execute fallback logic to process the request. Use case, get data from the Redis. Use case is get data from the Redis. If Redis logic is failing, then we should get data from the database. If Redis logic is failing for 3 requests continuously, then execute the DB logic for 30 minutes. After 30 minutes, retry for the Redis logic execution. If it is working, then execute the Redis logic only. If 3 retry executions failed with the Redis, then execute DB logic for next 30 minutes. So what is the circuit breaker? That you can understand here. Use case. Completed all of you? All of you able to understand what is circuit breaker? Yeah. Now here guys, we need to understand how to develop a project with a circuit breaker design pattern. So Spring Cloud Starter, circuit breaker design pattern, dependency available. In our project, we need to add this dependency. Then in order to enable the historics, we need to write this annotation called enable historics annotation in the boot start class. So in the boot application, we need to have this dependency. In the start class, we need to write this annotation. And here we are going to write a method. That method will contain the circuit breaker configuration. If some exception occurs in this method, then my fallback method will be executed. Okay. So like this, we are going to implement circuit breaker. Mainly 3 changes we need to do. One is new dependency we are adding. That is circuit breaker dependency we are adding. Enable historics annotation we are configuring. Then we need to specify circuit breaker configuration in our methods. Now I have that project ready, guys. Circuit breaker application. Go to pom.xml file. So if you see in the circuit breaker project pom.xml, web starter dependency is available, circuit breaker dependency is available, dev tools dependency available. Web starter is available and circuit breaker dependency is also available. After adding this dependency, now if you go to our start class, in the start class, we have normal annotation, boot application annotation. Along with the boot application annotation, I'm configuring one more annotation called enable historics annotation. I've configured one more annotation called enable historics annotation. Then we are having a REST controller. As I told you, I have written one method called get data from the Redis method. Get data from the Redis method. Now, in this method, I am going to throw some exception. I'm getting some random number. If the random number less than or equal to 10, then it is going to throw some exception. Okay, guys. Now, here I am having get data from the DB. Here get data from the Redis. Here get data from the DB. So this is my main logic and this is my fallback logic. This is main logic and this is fallback logic. Clear? Now here if you observe, I'm writing one annotation at the rate historics command. This is my Redis method. So now here in the Redis method, I'm writing one historics command. For this historics command, I'm giving the fallback method is equal to get data from DB. That means whenever exception occur in the Redis method, I want to execute DB method as a fallback method. So when the circuit breaker should open, when the circuit breaker should be closed, here I am giving historics properties, request volume threshold value is equal to 5. If 5 requests are failed continuously, then go for the fallback method directly. Sleep window in milliseconds, I have given 10,000 milliseconds as a sleep window. How many times? How much time? Only secondary logic should be executed. When the secondary logic should be executed, that we can configure by using historic property. Historics command I'm taking. In the historics command, I'm telling my fallback method is this. So my request will go to this REST controller method. This is my REST controller. In this REST controller, I'm having a method that is mapped to get request slash data. For that method, I'm having a historics command. So fallback method is equal to get data from DB. Command properties. So request volume threshold, sleep window in milliseconds. Request volume threshold means how many requests you want to observe for the exception. If any exception occurs for all these 5 requests, then circuit will open. It will execute only fallback method for 10,000 milliseconds. After the given time is completed, it will retry to execute my Redis method. If Redis method is still failing, then we'll execute fallback logic. Okay. Now let us see here the response and let me run this application first. Getting the data from the Redis, that is main logic. If the main logic is not working, then only I want to get the data from the database. That is my secondary logic. I have started my application. Application started, guys. So let's wait some time. I'm trying to run this application. It is taking time to start. So meanwhile, you observe whatever the historic command I have given for the main method. Yeah. Application started. You can verify. Publish subscriber. Circuit breaker started, guys. Channel 1, subscribe histories. It is available. Now, our server is running on the port number 8080. Okay, guys. Running on the port number 8080. /data is my URL pattern. Now go here. Localhost / 8080/data. So actually, I'm sending the request. I'm sending a GET request with the /data. /data URL pattern map it to which method? Map it to which method, guys? Redis method. What output I should get? Data accessed from Redis, main logic is executed. If not, data accessed from database, fallback logic. So error should not come to the client, either first method or second method. First method is my main method, which if it is failed, then I should get the fallback response. Now, send a request, localhost / 8080/data. Localhost / 8080/data. Now, guys, exception occurred in the first method. So I got the response from the first method, or I got the response from the second method. Guys, observe. I got the response from the first method, or I got the response from the second method. I got the response from the second method. I'm sending the request for the first method, but I'm getting the response from the second method. Why? So here, my second method does not have any URL mapping also. Only my first method is having the URL mapping. My first method is having the URL mapping. My first method is having the URL mapping. My second method does not have the URL mapping. I'm sending the request to the first method. When I send the request to the first method, but I got the response from the second method. You see in the console, clear that console. Now, send one more request. Second request I'm sending. Now I send the second request. Now you see, Redis method called, it got failed. First Redis method got called, it got failed. Then database method got called. So I'm sending the request to first method. First method is failed, then automatically fallback method is executed. Now send the second request. Now again, Redis method called, then DB method called. Then one more request, Redis method called, DB method called. One more request, Redis method, DB method. Then one more request, Redis method, DB method. Send the multiple requests here. When I'm sending multiple requests, you see only DB method is calling. So now it will observe for 5 requests. It will observe for 5 requests. Redis method is called, it failed. Then go to fallback method. Second request, go to Redis, failed, go to fallback. Redis, failed, go to fallback. Redis, failed, fallback. Then after some time, only my fallback method is executed because it already observed. Couple of requests observed. Couple of requests are failed with the main logic. When the main logic is failing, why to call that again and again? That's where circuit breaker comes into picture. Circuit breaker will execute only fallback logic. Now after some time, again I'm sending a request. Now what happened? Redis method called first time. Now it failed. Then DB method. Then send the request multiple times. Now only DB method. Only one time in between Redis method called for the retry. Still the Redis method is not recovered. It is failing. When the Redis method is failing, then the next requests are going to only fallback logic. After some time, again send the request. Now what happened? Redis method called, it failed. Then DB method called. Send the multiple requests, then only DB method is calling. Now circuit breaker is working or not? Guys, circuit breaker is working or not? Circuit breaker is working. Can we achieve this? Can we achieve this functionality by using try-catch block like this? When the main logic is failed for 5 times continuously, then only second logic should execute. When the main logic is failed continuously for 5 times, I want to execute only secondary logic for some time. Okay, guys? When the main logic is failed continuously for 5 times, then I want to execute only secondary logic. We cannot do that by using try catch block because always a try block will execute. If it fail, then it will go to catch block. Try block will execute. If it fail, go to catch block. Try block will execute. If it fail, go to catch block. But in the circuit breaker, what happened? 5 times if the main logic is failing, then from 6th time, automatically it is calling only fallback method, not the main method. Observe this once again. Go to the console, clear the console, send the request. Redis method called, DB method called. One more request, only DB method is calling. One more request, only DB method is calling. Multiple requests, only DB methods are calling. In between, Redis method called, that is called retry. So automatic retries are happening. When the retry is happened, if a main method is executed as expected, then it will go to only secondary method. See here, first time it is calling the actual method. It is failing. When the actual method is failing, then it is calling only secondary method. But request I am sending for first method, but automatically that circuit breaker is open and that circuit breaker is calling my secondary method. You see, in the first method, is there anywhere, am I calling the second method or automatically it will be called by circuit breaker? You check the logic. You check the logic. First method, bind it to get mapping with a /data URL pattern. Now, manually I'm throwing some exception by using some random number. So whenever the exception occurs, then automatically you should go to my fallback method. I'm not calling the fallback method from the main method. Circuit breaker will divert the traffic from the first method to second method if continuously 5 requests are failed. The circuit breaker is bypassing the first method execution. So this is one design pattern in the microservices. When the main logic, when the actual logic is failing, instead of sending the error response to the client, we want to send some fallback response to the client. We want to send some fallback response to the client. Are you guys clear? Are you guys clear with my point? Circuit breaker. So what are the steps that we have followed to implement circuit breaker? So adding this dependency in the pom.xml, we are adding Spring Cloud Starter Circuit Breaker dependency. In the main class, we are writing one annotation called enable histories. Then in the REST controller, we are writing one method that is mapped to get request with /data. If some problem occur in that method, then it should call the fallback method. When to call the fallback method, that we are configuring by using histories command. Fallback method is equal to which method you want to call. When the main method is failed, what is the alternate method to execute? So what is the request volume threshold? How many requests we want to observe to call only secondary method? Sleep window in milliseconds. After how much time? Retry should happen. For every 10 seconds, I want to do the retry. Retry means execute the first method. If it is working, continue. If it is not working, then continue with the second method only. Like this, we can configure circuit breaker in our application. Now always I'm getting the response from the second method. Why I'm getting the response from the second method? My first method is failing continuously. As the first method is failing continuously, my secondary method is getting executed. Secondary method is getting executed. So are you guys clear? Are you guys clear with the circuit breaker? Fault tolerance system. When one logic, when the request processing is failed by one method, I want to execute another method as a alternate. I want to execute another method as a alternate. Clear? Fine. Good.